The final lesson in this unit is we're going to learn about the fundamental theorem of algebra. Here is your warm-up for today. So I want you to solve this polynomial, then turn the video back on and check your solution. So did you find any factors of 7 that the difference would give you 3? Nope, you could not factor that, could you? So you needed to use the quadratic formula. So you can check your solution here. The fundamental theorem of algebra, if p of x is a polynomial with a degree that is greater than or equal to 1, the function equals 0 has exactly n roots, including multiple and complex roots. So here are the steps to find all the roots of a polynomial equation. First of all, you need to put the polynomial in standard form and find all its possible rational roots. Remember p over q? When we find a rational root, so we're going to check it to make sure that it makes a true statement. Then we use synthetic division to find another factor. And we're going to repeat until the quotient is factorable or it is a quadratic. Then we will solve it. What does that look like? Well, we're asked to find the roots of this polynomial function. We're going to put it in standard form, which it is, and find all the possible rational roots. So our p, all the factors of negative 20, would be these factors. And the only factors of this 5 are positive or negative 1 and 5. So our possible rational roots, 1/5. We've got 20 divided by 5, which would be plus or minus 4. 2 over 5. 10 divided by 5 would be plus or minus 2. 4 over 5. And then plus or minus 5 over 5 would also give us again that plus or minus 1. We only listed once. So these are all our possibles. So what we'll need to do is substitute these in to see if we get a true statement. And apparently we found that 4/5 gives us a true statement. So we're going to use synthetic division. We bring down, we've got a 3, 2, 1, none, so we don't need any zeros, no placeholders. We bring down our 5, negative 24, positive 41, and negative 20. Bring down our first term. 4/5 times 5 is 4. Add. Negative 20 times 4/5 is negative 16. And add. 25 times 4/5 is 20. And add. So you see, again, we can determine that 4/5 is a factor because we get a remainder of 0. But because we knew it was a factor and got the remainder of 0, now we can have another polynomial. We started with x to the third, so now we've got 5x squared minus 20x plus 25. How do we get 5x minus 4? Set this up. If we've got x equals 4/5, to find out what that factor is, we're going to have to multiply both sides by 5. We're going to have 5x equals 4. Then we subtract 4 from each side. So we're going to have 5x minus 4 equals 0. That's how we get this 5x minus 4. So now we have a quadratic. Can we factor that? Well, if we pull out a 5 out of everything, that's our gut instinct, right? We're going to get x squared minus 4x plus 5. So you get factors of 5 you can add together to get a negative 4. No, that won't work. So we're going to have to use the quadratic formula. 20 divided by 10 is 2 plus I, and 2 minus I, and then the 4/5. Notice we have 1, 2, 3 terms, just like it says. Very good. Let's practice on another. 4, 3, 2, 1, none. Okay, so we've got this in standard form. Now the possible rational roots, factors of negative 18 over 1. So here are the factors of negative 18. Factors of 1 are just plus or minus 1. So our factors are going to be 1, 2, 3, 6, 9, and 18 if we write them in order. Let's find a rational root. Well, apparently when we checked our roots, we found out that 3 was one of our rational roots. So let's use synthetic division, put our 3 here, Bring down our 1, 1, negative 7, negative 9, negative 18. Bring our 1 on down and do our synthetic division. Now we have a depressed polynomial, x to the third, 4x squared, 5x plus 6. And we know that this x minus 3 is a factor. We also, because now we're at x to the third, we're not at a quadratic yet, we found another rational root was negative 3. So we're going to take, we found x minus 3, and this was the depressed polynomial we got. Now we're going to do this negative 3 with this one. So we write 1, 4, 5, and 6, and do synthetic division. Our answer will be x squared plus x plus 2. So we've got factors of x minus 3 from before, x plus 3, and x squared plus x plus 2. So now we've got a quadratic. We need to solve the quadratic. We don't have factors of 2 that will add up to be 1, so we're using the quadratic formula. So all of the factors, all the roots of this polynomial were the 3 and the negative 3 we found earlier. And then we've got the negative 1 plus I, square root of 7 over 2, and negative 1 minus I, square root of 7 over 2. Very good. Now it's time for you to practice on your own.